Hi everyone, my name is Keeley Takimoto. I am the Modules Program Lead for the Division of Computing, Data Science, and Society at UC Berkeley, and I'm here to talk to you about some of the programs that we offer around curriculum outside of our flagship data science classes. So in this talk we will go over the Modules Program, Data Science Connector courses, and Data-enabled courses. And not only are we going to cover what each of those things mean, because many of these courses are somewhat specific to Berkeley and how we talk about them, I'd like to start off with the overall vision for inclusion across campus that has shaped the development of these different programs and courses. And before we wrap up, I'll show you some examples of the materials for these different courses. So what was the motivation? Why create these oddly named new course systems? It really comes from a core value at the Data Science Education Program around inclusion of all students. We believe that any academic area can be enriched by data science approaches, not just the ones that traditionally already have included a coding or stats component. We think that this is also an important issue around inclusion as well. Any UC Berkeley student, or really any college student, can be enriched by data literacy skills. Our students generate data every single day, from the way that they use their devices to information that they give to websites or other data collection sources. And their information is being used to make decisions that affect their life, whether that is policy or industry and marketing. So it makes sense that we would want our students to have some kind of data literacy before they graduate on how data may be used, what it excels at in terms of data-informed decision making, and what are some potential biases or areas that can be used to enforce systemic oppression or discriminate against certain populations. We've also developed these programs around the pre-existing infrastructure that was built for the Data 8 course. It makes it easy for students to access data science teaching materials without a whole lot of setup ahead of time or without expensive computing equipment. And finally, we wanted to use Jupyter Notebooks as a pedagogical tool in other classes. We think that this format allows students to explore the stories that can be told by data, to interact with code, and see it applied right before their eyes. So the Data Science Education Program is also committed to working with diverse types of instructors. Ultimately, you can think of the whole program as having this modular architecture where a lot of areas of interest and applications of data science are in different domains, whether that's psychology, sociology, biology, or humanities like rhetoric or legal studies. In some way, you can think of the whole program as the unit of pedagogy rather than an individual course such as Data 8. And there's definitely a coalition building aspect here. In my position working with Modules Program, I've gotten to meet amazing professors from all across campus and share knowledge back and forth about how computational methods may be applied to their domain, how their students are interacting with these methods, and what would be useful to teach their particular subject in 2020. The goal here is to emphasize that we are not the owners of data science. Data science is very much a collaborative, interdisciplinary process, and we cannot make curricular materials without the input of the real domain experts, such as professors or grad students. So to start, I'm going to talk about the modules program. A data science module is a short exploration of data science that is built in a few lessons in an existing class, and that class often comes from social sciences or humanities. Modules are typically built by undergrad students who are working with the Data Science Education Program and distributed using Data 8 infrastructure such as NB Gitpolar or the Jupyter Hub. With the Jupyter Notebooks that are made for modules, a lot of the code is pre-populated. We want students to be able to see computer code and access it and even edit it, but we don't want to put the pressure on folks to write their own code, especially if they're not in a programming class. So we abstract away a lot of the technical details to let them focus on key concepts from the class or key quantitative methods. Finally, the students that work on these modules also will often attend lectures or lab sections for the course itself to help walk students through the process and cover technical details that perhaps the grad student or professor are not as familiar with. You can check out more data science modules, including documentation of our process, at our website. That is ds-modules.github.io. And if you're looking for the materials themselves, those can be found on our GitHub site, github.com/dsmodules. Modules has had a strong relationship with American Cultures classes. So American Culture, or AC classes, are a requirement for undergrads at UC Berkeley. They tend to be on the larger side, 200 to 300 students, and because every student has to take them and doesn't have to take it in a particular domain, they tend to attract a diverse crowd of students, many of whom have never done coding or stats or have actively avoided doing it. So we have been lucky enough to work with many enthusiastic professors teaching these courses, which the courses also often incorporate themes of social justice, social impact, or data for societal good. And by bringing this data science component in, we can make that connection more explicit of how data can be used in policymaking or to bring a different lens to this domain. So moving on, I want to talk a little bit about the data science connector courses. These are courses that are associated with Data 8 and focus on applications of foundational data science in a specific domain. You can see some of the previous connector courses on this slide here. Connector courses tend to be about 2 or 3 units, which is lighter than a typical workload for a full major requirement class. They're often taught by the domain instructor, so somebody who has expertise in cognition or history or so on. A few of them do satisfy key prerequisites in conjunction with Data 8, so they can help students further their degree programs. Others are very unique explorations of domain expertise. It's a great opportunity for an instructor to connect their work in a very applied sense to the data science methods that students have just learned about in Data 8. We have a GitHub page for connectors as well. Many connectors, although not all, can be found at github.com/ds-connectors. And what is on the GitHub pages tends to be the Jupyter notebooks used in the class, usually a README with some more information about the course. One example of a connector course is called Data 88, which is on economic models. It was taught by Data Science Education Program's own Eric Van Dusen. And you can get a sense of the course by looking at the course calendar, which you can see the website on the left. And on the right is an example of using IPython widgets, this slider tool, to program what are pretty sophisticated visualizations and let students interact with them by moving the slider back and forth rather than having to write complex code themselves. So data-enabled courses are the final set of courses I want to talk about. This is a course that's designed around data science in a specific domain. And it tends to be upper-level courses that assume students have had some background in programming or stats. They often have an extensive set of specific notebooks, multiple notebooks for each week of the course sometimes. And it can count for a domain emphasis requirement for the major or an elective for the minor. Data-enabled courses are less frequent than modules or connector classes because there is a lot of work that's put into creating that notebook set with deeply embedded domain data. But we have some examples here, including Economics 101B by Brad DeLong, Energy and Resources 131, Duncan Calloway, and Legal Studies 123 by Professor Jonathan Marshall, which I'll talk about at the end of this presentation. So let's get to some examples. What does this actually look like when we're creating materials to use in non-data science classes? I'm going to start by talking about Ethnic Studies 21. This is an American Cultures class. And this professor, Victoria Robinson, wanted to bring data science to talk about this topic of prison overcrowding in California. Professor Robinson already has a wonderful way of presenting this that has formerly incarcerated people as guest speakers to give their firsthand accounts of what it's like to be in the California prison or jail system, especially before and after a major law changed how prisons can admit people that are incarcerated, so the amount of overcrowding. So here we have the data set, which comes from the California government. And in the module itself, students were able to create and analyze these visualizations. So on the left, you can compare prisons by gender, looking at what percentage of inmates it was intended to hold, as well as the staffing percentage. You can see another example of a widget on the right side, which allows students to compare different institutions in California and see how the trends of percent occupancy changed over time. Sociology 130 is another American Cultures course, and this module has run maybe 4 or 5 times now. This was an idea from Professor Joanna Reed, and we've also worked with Daniel Schneider. And it started by a project that originally didn't use code, where students went to a census tract along a bus line that they can access with their Berkeley bus pass and collected data about that specific neighborhood. How much trash they see on the street, did they see broken windows, did they see positive amenities like grocery stores. This was combined with census data inside a Jupyter notebook to create some really wonderful maps. The maps allowed students to visualize the data that they had collected and submitted through a Google form. The developers who created the notebooks then turned those submissions into this map overlay where we can see where observations were taken, what was observed by each student. In this example, we can see the photo they took as well as their description of what they saw. And we also used that census data to overlay choropleth maps. That allowed us to see what are the demographics of these different census tracts, what is the median income, what average level of education, and does that track with the data that the students collected themselves. Yet another American Cultures course is Stigma and Prejudice, working with Professor Rudy Mendoza-Denton. And this project allowed students to choose their own data set and explore relationships between implicit bias and health outcomes. So you can see an example of the data set on the left that has some scoring for implicit bias. In this case, it's young versus old, and a real health outcome like heart attack mortality rates. Ultimately, this took place over 3 different sessions where students learned some very targeted Python coding, just the Python that they needed to complete this assignment. They saw examples of comparing implicit bias to some health outcome, and then they chose a different set of variables to plot a regression line and calculate significance testing. Moving on to a lab course. This spring we were able to work with Biology 1B, which is a general biology lab. It was our largest class yet at 700 students for this module. And this was an interesting case because the module deployed after shelter in place due to COVID-19 had started. So for this first lab, students would normally visit Strawberry Creek, which runs through campus, and take samples and then analyze those samples using biological measures of diversity. Students were no longer on campus by the time this lab happened, but because we were using the Data 8 infrastructure, a GSI, a grad student instructor, was able to upload a sample data set to the cloud servers that all students could access and still complete the lab from home. So you can see some of the charts that students used to compare measures of diversity on the bottom left. And biology also used another innovative way to engage students in lab classes from home, which is simulation. This is a famous predator-prey interactions lab where students are looking at how population sizes of predators and prey change over time based on the starting populations, the rates of reproduction, and the rates of predation. This is definitely a major example of a lot of widgets. So students were not being asked to code any Python, but using all of these different sliders, they can adjust the population parameters and see what happens under different circumstances. At one point, can they achieve equilibrium between predators and prey? At one point, does one population go extinct? We've had the pleasure of working with a couple different lab classes now, specifically Biology 1B and Molecular and Cell Biology 32. And we think this is a really cool application for Jupyter Notebooks. Jupyter Notebooks allow students to gather their data, calculate using formulas, graph results, and write up their conclusions all in the same file. Versus traditionally, a student might be writing their observations on paper in some sort of lab book. They might be then entering those observations into a spreadsheet like Excel, opening up a Google document to write up their results, and maybe even using another piece of software to create graphs. So we think that this is potentially the future for lab classes using Jupyter Notebooks. My last example I want to touch on is Legal Studies 123, which is a data-enabled course looking at data, prediction, and law. So this course in particular had, I think, about 2 labs every week, all in a Jupyter Notebook, as well as a project that used the skills that students had built. Because they were doing so much integrated data science, students were able to get a lot farther than a short course like modules or even a connector course, where we're assuming students are coming in with no knowledge. A good example of that is the exploratory data analysis lab that they did within this class. The students were analyzing texts from presidential campaigns in the United States in 2016, including campaign speeches. And in this lab, it occurred fairly far into the course. It was maybe week 10 or 12. So by this point, students already understood a lot about data cleaning and processing, and the lab could get into the idea of chunking data, parsing data, splitting a long string of text data into specific words or word roots. That could be gotten through pretty quickly, and we could focus on things like visualization and exploratory analysis, as well as dimensionality reduction. So on the left, we can see an example of looking for particular word frequency in different candidates' speeches. And on the right is an example of the data for all of the political speeches mapped in a 3D plot after using latent semantic analysis. We're getting into dimensionality reduction and preparing to do machine learning techniques. And this is a really interesting graph because you can see that there does seem to be some separability in Republicans in red versus Democrats in blue. Something about the way that they use words or order words in their speeches seems to be different by party. So I mentioned a lot of links during this talk. I've collected most of them in one place. If you're interested in learning more about the program, I highly recommend you check out our website. At the modules and connectors websites, you'll see examples of notebooks, you'll see the links to the repository that has the raw materials, and you'll also be able to interact with the notebooks and get the experience of what it's like as a student to go through such a notebook. You're also welcome to email ds-curriculum@berkeley.edu if you have further questions. And thank you so much for listening to me talk about modules and connectors. If you have questions, don't hesitate to reach out, and I hope you enjoy the rest of the National Workshop.